This is another example of optimization problem. If you wanted to find two positive numbers whose sum is 110 and whose product is a maximum. That's an optimization problem. Okay, so we're looking for two numbers when you add them together. So x plus y equals 110. But when you multiply them, you get the most you can possibly get. So for example, two numbers that add up to 110 would be like 100 plus 10. When you multiply it, 100 times 10, you get 1,000. If you did something more like 90 plus 20, that also equals 110. When you multiply it, you get 1,800. So you could do this by trial and error. 80 plus 30, and all the numbers in between here, like 91 plus 19, and every product all the way down. So this also equals 110. 3 times 8. 3 times 8 is 2,400. So you can see the product is getting larger. We want to maximize the product while getting the same sum. So you could do this by trial and error, and you could keep going all the way down until you find it. And it ends up being exactly 55 plus 55 equals 110, and then you get a maximum product over here. But we're gonna do it using calculus. So we have, this is our secondary function right here, and this is our primary because this is the one that we're trying to maximize. So we solve the secondary for one variable and plug it into the primary so that we only have one variable in the primary. So if I were to solve this for y, it would say y equals 110 minus x. So now instead of calling this x times y, I can call it x times 110 minus x. So I'm substituting in this variable into here. If I distribute that, I get 110x minus x squared. This is what I'm trying to maximize. This is my composite function. It's one function plugged into the other. So it has the restriction that we have this sum of 110, and we're getting a product. We're trying to maximize this. So we want to take the derivative, set it equal to 0. So the derivative of this is negative 2x plus 110. Set that equal to 0. Negative 2x equals negative 110 divided by 2, and you get x equals 55. And when you plug it back in, you find out that y also equals 55. And so, again, you could do this by trial and error. It just takes longer. All we have to do is find a primary, secondary, plug it in, set it equal to, take the derivative, set it equal to 0, which means you're finding a critical point, which critical points are generally mins and maxes, right, of a function. So you created this composite function, and right here rather, and then you're taking the derivative to find the mins and maxes. So in this case, the max ends up at x equals 55. And so that's just another example of an optimization problem.